the only remaining thing to do is now we want to, this needs to be encapsulated. C++ is an object-oriented language. And so really, if we're going to have a person, we ought to make a person object. We ought to write a person class and encapsulate what a person is and what a person does inside of a class. So we're going to do that next. Instead of using disconnected globals, let's encapsulate the data members into a C++ class and create or instantiate a person object. So to modify this, I'm going to hop up here where my globals were. Instead of using a bunch of loosely disconnected, discombobulated globals, we're going to encapsulate everything into a class as we should. And of course, we'll call it the person class, open closing braces that are semicolon to terminate the class specification. With any class, we need to have the modifier. So we'll make our constructor and destructor public and our accessor functions or methods. In the public area, let's declare our constructor, always the same name as the class. No return type, not even void. Tilde. And the destructor as well, same name as the class, but with the tilde in front of it. Don't really have to do anything here, but again, I kind of like to provide a little feedback. And let's do building a person, and then we'll come over here and we'll do destroying a person, okay? And let's see, destroying a person. Let's incorporate the previous globals as private data within the class. Now we're going to make our private data section, okay? And let's take our disconnected, discombobulated variables here and put them inside of our class and encapsulate them all into an actual person object. Alright, so here, we'll go ahead and declare them, and white space isn't important, but I'll tab it over, it makes it easier to follow. So we have 4 strings, and that's private if we're following our class convention. So in the public area, we need to write accessor methods, alright? So I have to have accessor methods to get at that data. Now I need to write public accessor methods to access the private data members. Now I have to create public accessor methods for our private data, and we'll just need a get and a set. Remember, the set is always going to have a void as a return type. It doesn't have to return a value, but it needs to accept arguments or parameters. And so we'll call this one set person name. And that's usually my MO. I just call it set and prefix it in whatever the variable name is, whatever you want to call it there. But we need to take the appropriate type of argument, so string X. And the way it works, remember that the private data goes on the left, and use the assignment operator and take the argument or parameter on the right. It comes in as public and assign it to the private data. Okay. And using that as an example, I'm just going to write 3 more sets all the way down. And let's see, occupation. And next one we will do is location. And the next one we will do is references, okay? And again, let's make sure we assign it to the right value, location, and references. Alright, so those are the set methods: person name, occupation, location, and references. And now we just want to do the get. And the get is sort of the inverse, the flip side, the opposite of the set. Whereas the set has no return type, it takes an argument. The get usually returns a value, but it doesn't require parameters or an argument. And it has to match the data type, right? So again, I have to return a string, just as I had to accept or take a string as an argument here. And we'll call it, same thing, person name, no arguments required, and just a keyword return. Its only function is to simply return the private data through a public function. And remember that you do this in C++ and Java to sort of protect your data or shield your data. The public functions or the accessor methods act as sort of a gateway to the private data, and it helps you prevent inadvertently accessing one object's data from another when you don't want to or when you shouldn't. And let me go here and here. I mean, I could just have made them all public and access them directly, but that's kind of bad form. You kind of want to keep your data private and always access it through a public accessor function or accessor method. Alright, so now we have a person class. We've taken all that loose data and we've encapsulated it inside of an actual object. It's a class. So it exists. Now, the only thing we have to do is we're going to have to build that object and then call the accessor functions on it in order to set and get the data to actually use that object. Right? So it's sitting here, and I would have to prototype the class if I didn't define it before main, but I don't have to since I defined it up here. So let's look at the remaining changes we have to make now because we're using an object. Now that we have written a person class, we must be sure we build or instantiate a person object from that class on the heap or stack before we use any of its data or methods. So the first thing I'm going to have to do before I can actually manipulate this data is I have to build the object. Remember, a class is just a blueprint for something, but it doesn't actually, nothing actually exists or is capable of doing something until you take that class and you build something from it, build something from the blueprint, so to speak. So there's the person class, but I have to build an object from the person class. And then we'll use its instance name to access the methods. So I could do it here inside of main, but there is a problem with that. If I were to simply say person, CG or Charles Germany or whatever, if I did that, well, this is local to the main function. Remember, anything you build in main is local to main. And so I'd have a problem accessing that object outside of the main class unless I passed it via argument to all the functions. And I could recode all my functions to take arguments to person objects if I wanted to. But then I have another problem. I'm building this on the stack, and if I did that, and I'd basically be passing by value. And so a copy would be made, and that would be expensive in terms of memory and CPU cycles. All those extra copies. It'd be more efficient to pass by reference. And so I could then turn around and recode all my functions to take an argument via pointer. In other words, to accept an argument by reference instead of by value. We talked about that before. But another thing that I could do that would be even easier is I could, instead of building this on the stack, I could build this on the heap. Okay? And what I would need is, I'm going to cut this out here. Remember, when you build something on the heap or the free store, you have to use a pointer to point to it, so to speak. Okay, so I'm going to come over here and I'm just going to make a pointer to it. CG will now become a pointer to a person object, not an actual person object. And if I do that, then I'm going to go down here and in the create person object, I'm actually going to take CG and build a person. Now, I'm doing this to illustrate something. I'd probably want to do this automatically, or else do some serious bulletproofing with booleans or such, because here's the problem. As long as I do this first before I do anything else, try to edit a person or display a person, I'm good. I'm fine. However, if I don't do this first, and then I tried to display a person and it was null, that pointer points to nothing, I'm going to have problems. My program crashing and all kinds of bad things happening there. So I just want to make sure I build the person. So in other words, I want to take this, and where I'm doing this, I want to come up here before I even displayed the menu or allowed the player to choose any of the options. I want to make sure that I build that object. Now let's modify our functions to use a person class object instead of disconnected global variables. So now we just need to go through our functions and modify them to use our class object. And remember, we can't access the private data directly by design, but instead we set it up so we have to go through these public accessor functions. So we'll have to use get and set. And create person is fine as it stands, but edit person is the first function we really need to modify. We're no longer using these global variables here. We're using our class object, the person class. And so what we need is, I'm going to set up a temporary string here. Okay. And then I'm going to get the value of that temporary string. And then once we do that, that'll account for spaces and whatnot. Then we simply need to use our object, which was CG, remember? Oops. Use a dash here, but let me scroll up here. Remember that it was a pointer. If I go up to the top here on our globals, CG is a pointer to a person object. So when we call create person, it's going to build it on the heap. And now, indirectly, we need to access those methods. So we have to use we're using a pointer here, we have to use the arrow to get it on the heap. So in this case, I want to call all the sets. Alright, so once I get my data with spaces using getLine, I'm going to call the sets, and I'll just pass in temp like that. So we want to do this all the way down. And again, I'm just going to replace all of these with temp. And I just need to come in and utilize the appropriate accessor method, the set method, to put this data in the right place or store it in the right variable. So there's person name, and then I just want to go through and occupation. and location and references. Right, so set references, set location, set occupation, and set person name. And we're just recycling that temp string right there. Alright, so that takes care of the edit where we need to use the set. Now what about the display? Here's where we have to use the get. But it's going to be something similar, right? CG, which is our pointer, and then it's going to be get, and then the way we set it up, it's just the get in front of the prefix in front of the variable name. So use it all the way down. There's our object, and then I'm going to set up our parentheses. Just call our accessors, and our public accessors will return that private string data. All right, so that converts our next function. 2 down, a few more to go. Now, when we save, again, I need to, I need the functions that return a string, right? So in this case, I'm going to want to call CG, and this time get. I'm going to return a string, and again, I'm just going to set that all the way down. Get, and then let's add our empty parentheses. All right, and then that's what we'll do as far as writing the data. On to the next function, and now here, I want to do something similar. Again, I need kind of a temporary string, so I'll just set up a temporary string up here, and it's local, so we can call it the same name. Ooh, string. I can't talk and type at the same time, but there, string. All right, so when I do that, let me come down here, and actually I'll leave that. Add a line here. All right, so we're going to read the data. We'll use getLine. We'll put that in temp, and then I want to call the accessor. And this time I'm going to use the set. Person name and temp. Okay, and we just want to kind of do that all the way down there. So I'm going to add some lines here, and I'm going to copy this to the clipboard. Let's recycle temp, our string, and then let's go down and use our accessor all the way down. And we just want to make sure. Bear in mind, we want to be careful. When you write all the data, all the data members or items in a class to a file, it's called serialization. And we just have to be careful that we read back in the order that we wrote, or we'll have problems. So the order that we wrote or saved was name, occupation, location, and references. We have to be careful that's the order that we read things back in. So name, and then the next, otherwise we're setting the wrong data, in the wrong string or the wrong field. So name, occupation, location, and then finally references. All right, references are okay. All right, references, and then we'll close our data file. Okay, so we're serializing now, and name, occupation, location, references. I always double check, and name, occupation, location, references. Okay, as we read those lines there. And since we're using getLine and not just streaming it, we can also handle spaces and things like that. Alright, so let's build the project, and odds are after making all those changes I might have a syntax error or two. Maybe you spotted one. Let's see. Oh, well, that was pretty lucky. Alright, so we've converted our project here to utilize a class structure the way we should in an object-oriented language like C++. So let's just go through and see how file access, how ifstream and ofstream work in this fashion. In the proper order, we need to make sure we build or create an object first before we do anything with it. So we'd want to build it first. And I did that manually just to show you, but likewise, even here, I'd want to be very careful. For instance, when I have the code here to load a person, I'd want to come down here and I'd want to take my pointer, and before I try to call any of those accessors, to be careful, I'd want to say CG is equal to a new person. And build a new person here. Use the assignment operator and build a new person. If I could talk and type at the same time. I want to build a new person on the heap there. Okay? I don't want to call this without having built this, or I'm going to have big problems. Crashes and bad things could happen. But, as long as I'm very careful to follow the proper order, I'm not going to do it automatically. I'm going to leave it, I'm going to leave it up to the user, so to speak. Alright, so we're running it. And we have built the person. Now that we built the person, let's go call edit and enter our name, Charles, Germany, and our occupation, adventurer, and Explorer. I don't know, whatever. Sounds exotic. Daytona Beach does not sound exotic. You might think it's great, but if you live here, it's not that great. And then references. Let's see who's. Of course, I am like this with Princess Zelda. We are just like peas in a pod. And me and Link, we hang out. And Midna, she's cool, and well, in my dreams anyway. If you're a Zelda fan. Okay, so we edited the information, and were we to display the information, here's how it comes back to us. We captured all the spaces. Everything looks good. Now let's save a person. We're going to save a person. Success. Data was saved to the file. And let's open it up and take a look at the file. I always do this just to make sure. Princess Zelda, Link, Midna, Daytona Beach, Adventure and Explorer. Okay, it looks like it got all the information. It looks good to me. And I'm going to quit, exit, press space. I'm going to run it again. This time I'm going to load the file. Now again, I'd want to put code in there to automatically build a person. If I were, just in case the player were to hit L, I know, being the programmer, I have to create a person first, and that's the point I'm trying to illustrate. But you should code your project so that, that's just bulletproof. It's automatic. You should either build a person when you start, maybe in main, or, maybe build a person and load just in case they load before they, otherwise you need to make sure that somehow, somewhere, in some way you create a person first, and then I can load a person. I load a person, and now I can display a person. And there's all my data. Charles, Germany, Adventure and Explorer, Daytona Beach, Princess Zelda, Link, and Midna. Alright, so I tried to go through different ways of doing ASCII file access with ifstream and ofstream, implementing the header file fstream. Doing it just with plain old string literals and text and no class, and then also doing it with an object. Doing it with cin and getLine, and just streaming the data versus using getLine to also do spaces. So just some things that you might want to think about as you go through some of your projects and begin to implement file access. Here's an example of ASCII serializing an abstract data type in a class hierarchy for an RPG game. This is just another example of file access where we are serializing a class. And so in this case I have a parallel inheritance hierarchy set up. And the player is basically built from this ADT, or abstract data type, the character class. So if I come down here, all the items of data that we need to save when we serialize it would be these items here. So the character's attributes, inventory items, booleans and things used in the game. In addition, there are also these globals. This is just pretty much environment data. And it tells whether or not they fought the giant or fought the dragon. So if they come back, they don't have to fight it again. And they'll, instead of seeing a giant who's trying to kill them, they would see their defeated opponent or foe. Or if they find the healing potion in West 2, they can't find it again. They'll come back and find an empty room and so forth. So environment data and class data. So what we have to do is save it. So in the first example, we'll take a look at the save character function. And we create a couple of C strings here. And we give the game an extension of .gam. We're just concatenating here. Okay, and this separate C dialog launches for load and save. They're like little mini windows. And this just gets whatever the player types in there, right, as a C string value. Come down here, we build our instance of ofstream called writeStuff. We open our file, which is whatever they typed in, concatenated with .gam, so the character file.gam. We're just checking to see if anything went wrong. We'll just return false, and we'll display an error message. Otherwise, if things go okay, then let's check, and we're going to go ahead and save the password to the file. And remember, the order is important. So we name the file what the player tells us to name it, and then the password goes in first, and then after that the character's name, and then hit, attack, defense level, and so forth. Now, when you serialize a class, it's very important that you read it back in the exact same order that you wrote it. Because I'm using lines as a delimiter, so I wouldn't want to take hit points and load them into name, or I wouldn't want to take password and try to load it into defense, so to speak. So when I write the load function, I have to very carefully follow the save function and make sure that I continue to do things in the same order, or that I continue to read things in the same order in which I save them. Okay. The other thing I have to do is I have to convert here, because I'm using C strings. I have to take a character array. And I'm simply going to loop through character by character, and I'll copy each character from our character array, or from our C string to a character array. All right, and then once I do that, I can write out the character arrays. But if I were to write out the C strings, I would just get junk and garbage characters. So I just had to kind of like write my own conversion there in a for loop. So that's all that's happening right there. So we go through, we write all the data. That's all the character data. Now this is all the environment data, the booleans and so forth. And then finally we get down here and we're closing the file object. Okay. So why don't we test the game, and we'll launch the C dialog and start it. Okay, and we'll go through here, and we'll just kind of go through the game and wander around and maybe find some inventory items. Let's see. And let's see. Up over here. And let's see. Alright, so we have these inventory items now, and just to show, we'll vanquish, or we'll fight one, let's fight one foe here, so to speak. And to the north, Magnificent Red Dragon. Alright, and use a healing potion. Alright, so I've defeated a single lone dragon, not any giants, and so forth. Anyway, this is just the data here, so I'm going to save in this location. This is like basically East 2. Alright, so I'm going to create the save file, and we'll call it Charles Germany, and the password will simply be password. So I'm going to save it. Okay, everything was converted. Now let's go take a look at the file and see what the file looks like. Here's the file here that was saved, charlesgermany.gam, the GAM extension. And here's my password, there's the name. And then this is all the player data and the environment data. And the booleans are just converted to numbers, 0 is false, 1 is true, so to speak. Not like Java. Loading a file. Now that we've written the file, we need to look at loading a character or reading from a file. So I have these local variables, and I just did that to make it more transparent. I could have utilized less code with some nesting, but I thought that might make it more difficult to follow or confusing. So we're going to read the data from the file into these local variables, and then we're going to use the accessors to set the data. So right here we get the name of the file the player wants to load, and we automatically tack on or concatenate the game extension. We build an instance of our ifstream class, which we need to read. We open the file that the player specified. If for some reason we can't, something goes wrong, we'll display a message, hey, you can't open the file, something went wrong. Otherwise, let's load the password. And we'll get, we use getLine in case there's spaces or something, but we get the password, and then with the password, in this case I'm going to convert the password to a C string, calling the function here C string on the string value of password. And if it matches, fine, we'll open it. And if not, we'll come down here and we'll say incorrect password was entered. Okay, so just a little bit of password validation there, I guess, or protection. And then, okay, if the password is good, let me scroll up here, then we're going to load all of this information into our local variables. And then once we load all the information into our local variables for the player data, the serialized class, the environment data, then we're going to use, our accessor methods, and we're going to set that data. Alright, so here's the environment data, and we're setting all of the environment data. And here are the accessor methods where we're taking our local variables and we're setting that data on the class. Finally, we're going to close our instance of ifstream, and in this case we need to display inventory and stats. We want to make sure we built the character and conquest to update all of those things and change the update the player's name and so forth, and then we'll start the theme music. Okay, so just kind of an outline of what we're doing when we load a character versus what we do when we saved it. And let's test it out. So remember when we saved it, we were in the East 2 location in the map. So I'm going to click Start, and I'll give it a name that's not the previous name, Charles Germany. And let's go through, and we were in East 2, so I'm going to hop on over to the opposite direction, West 2. And then I'm going to say Load, and character file to load, and the password was all lowercase password. So we can load the file. Character is loaded successfully, okay. And when I do that, notice that now I'm in East 2. Here's all my inventory items, my name has changed, and I defeated a single lone dragon, so my conquests have been updated.